Hi, I'm Gwen and welcome back to my YouTube channel. So in the last few videos I've been doing some hardware modifications, and as such it was quite easy just to use the built-in microphone in my laptop. But listening back and editing those files, although it was perfectly workable, I was really disappointed with the quality compared to the lapel mic, which I use if I can. So then I remembered I've actually got a microphone that I could possibly use for this. And here it is. It is a Realistic PZM microphone, which stands for Pressure Zone Microphone. And it was kind of built from the early 80s to the mid 90s. And it cost about £30, and you could buy it from Tandy, which is a shop which is called Radio Shack in the US. And people at the time were saying it was a good budget microphone. And I remember reading Future Music magazine, and the song Your Woman by Whitetown was recorded with it, the vocals. And people kind of rated it, and it was cheap. But I never picked one up. Skip forward a few years, and I was around my buddy Counter Reset's house, and we were recording a demo. And he, lo and behold, whipped out of his equipment drawer a Realistic PZM. And he said, "Oh, you want to get one of these, Gwen? The quality is really good." And listening back to the recordings he made, it was absolutely great. So I got on eBay and I ordered one. Now, at the time, I could see there was quite a few mods you could do to the PZM to make it sound a bit better. Not that it sounds bad in stock form, to be honest with you. So the first thing that you can do is change the end to an XLR. When you buy these on eBay, they come with an unbalanced 1/4 inch. But actually the cable here is a balanced cable, and you can just solder on an XLR cable, and I did that straight away. And then I saw there's things you can do with the power. So it's got this kind of little power supply box here, which takes a AA battery, 1.5 volts. But if you look in the manual, you can put two 6-volt batteries in it and power it with 12 volts. What some people do, because those 12-volt batteries are a bit expensive, they convert the whole thing to use phantom power. And that is what I'd like to do. So first up, have a listen to the difference of the PZM as it is now, with the only mod done being the XLR. Hi, my name's Gwen, and welcome to my wonderful YouTube channel. Hi, my name's Gwen, and welcome to my wonderful YouTube channel. Compare it to the laptop mic and it's already a load better. Then I'll explain how you change the connector to an XLR, which is dead easy. I think everyone buying one of these should do that. And then I will, before your very eyes, have a go at doing the phantom power mod. Now, if you want one of these Realistic PZM microphones, they're still about 20 to 30 quid, and there's a few of them on eBay. They come up reasonably often, especially in the States, where I guess they were sold more. But let's get going. So here is how you would go about connecting an XLR connector to the Realistic PZM. Obviously, I've already done this, but it's very easy to do, so I don't think I need to do it again to demonstrate it to you. So the first thing you do is chop off the 1/4 inch connection which the PZM comes with. Then you strip the end of the wire, and you see there's two cores, a red and a black, and a screen. So to pin 1 of the XLR, you connect the screen. That's your ground. You connect the red wire to pin 2, and the black wire to pin 3. And you do hear a little bit of a difference. There's a bit less noise when you do this, and it's a lot more convenient to plug into a mixer as well. So now let's go and do the phantom power mod. All right, let's work on the mic. So when Radio Shack made these, they made a few unusual design choices. First of all, they used that unbalanced connector, but that's easy enough to fix. And the second thing is that this is actually powered using a positive earth. Now, I'm sure all of these changes were done in order to save cost and, release this great microphone at, the £30 price point. But phantom power is negative ground like most stuff is. So the first step is to change this setup to use a negative ground as well from using a positive ground. So the first thing to do is just remove the battery. And then there's 4 screws here which you can undo. So that case just pops open now to reveal the insides. There's the output transformer, and then all the other circuitry is contained in this metal box here. First though, you need to undo this screw here. There's one screw holding the circuit board down. Now you can lift out the metal box. There you go. I'll be a bit careful. So you notice that the black wire is actually connected to the positive terminal of the battery, and the red wire is actually connected to the negative terminal of the battery. The first thing we need to do is to remove the screening box, and to do that there are 2 metal tabs, one which is here at the top and one which is kind of 2/3 of the way down. So you need to desolder those. Now, I already did that earlier because I wanted to see how easy this would all turn out to be. So all I have to do is lift off the top of the button, this plastic piece which indicates on or off. Then I can lift that metal piece off. You'll have to desolder that, but it's quite an easy job. It comes straight off. I just sucked the solder off, then prized the tabs open with a screwdriver, and then it just lifts out. It wasn't a dramatic operation at all. So this has in it, just composed of this switch here, electrolytic capacitor, and 2 resistors. Now, some versions of this have only 1 resistor. I'm not sure at what point they changed to using 2, but if you look in the instruction manual, it comes with a schematic and it does only show there's 1 resistor there. In any case, we don't need to change those, but what we do need to do is, since this electrolytic capacitor is polarized, we need to switch it to go round the other way for the positive earth. Currently, the wire of the electrolytic, which is on the outer edge of the board, is the positive terminal, so we need to swap it round, so that's the negative. There we go. That's the 10 microfarad electrolytic capacitor successfully removed. Now we have to insert it back, but switched around. Right, that was done reasonably straightforwardly. The next part will be more tricky. So we need to change the wiring of the actual microphone element, which is in here. There's the metal plate, is quite substantial. And then in here, you can see some extra components. So there's the wire that goes to that power box that we've just modified. There is one small capacitor here, and right at the very end is the capsule. So I've removed one screw, and I will lift out a piece of plastic which is in front of the microphone element. And there we are, you can see it even more closely. There at the end is the microphone element, so we need to take that out. And I'm just going to use a small flat-bladed screwdriver. So on the base of the microphone element is this funny little end cap, which is held on by tape. But in my case, after 40 years, 35 years, the tape's disintegrated and that just dropped off. Here is the capsule. It's just got one black wire and one red wire. Now I'm not sure why you do this step, but it partially makes sense. So within this capsule is a field effect transistor, so clearly that depends on the polarity of the electricity that flows through it. Now what the instructions I found online says to do, though, instead of switching the two wires, which I would be most tempted to do, and it would probably be the easiest, it suggests cutting the small wire that goes between the black. There's a small PCB trace between that and the case, so it's just cutting that and then connecting the red to the case instead. Now I'm not sure why the instructions have that suggestion in, but I'm going to follow it because I presume they tested this and know what they're doing, and perhaps within this it makes sense depending on where the field effect transistor is connected. So I'm using a scalpel, but you could use some other kind of sharp knife. Let's see how close I can. Yeah, you kind of can see. So the black wire is here on the bottom. And there is a connection between that and the edge of the board, and therefore the case. I'm going to try and cut that trace now. Okay, I've got it on the buzzer setting just to check continuity. So holding one on the edge of the capsule, and I'll just touch the black wire. Yes, that is now disconnected. So I need to be gently and very carefully need to solder from the red to the outside of the capsule. And for this type of job, I find the best thing to use is an old resistor leg, and I've got some in the sponge of my soldering iron. There we go. That's just the discarded end of a resistor. I'm going to use that to go between the red wire on the capsule and the outer edge. This might take a few attempts, and I don't want to damage the mic. Whew, that was tricky. You definitely need to know what you're doing with soldering to do that. Okay, cool, that has worked. I'm not going to bother with the brass cap. I'm refitting the plastic piece on top of the element. And now at this point it probably makes sense to do a test. But don't forget we have to put the battery in the other way round now. So I'm inserting the battery backwards. Now you might say, well, why not just swap the terminals round? And I tried it earlier actually, but the problem is that they're different sizes, so you can try and swap them round, but the terminal which is connected to the black wire doesn't go in the other end. Which is really annoying because that would clearly be quite helpful. So I'm going to switch off my lapel mic. Realistic. Check, check, 1, 2. Check, check. And that is working well. So I'm going to reassemble the microphone onto the base plate and switch off the mic. All right, so I've mounted the mic back on its plate. Let's just give that a quick test as well. Check, check, 1, 2, 1, 2, mic check. That looks like it's working fine. So I've selected some 22k resistors. I'm going to solder them to the back of the circuit board where the red and the black wires from the XLR cable come in. So where the red wire from the XLR connector goes, I've soldered a 22k resistor, and where the black wire from the microphone goes, soldered another 22k. The ends of those are soldered together, and then I've soldered a flying wire from the junction of those two 22k all the way over here to where the red wire from the battery was originally connected. Now the black wire from the battery used to be connected here, and that goes all the way around this track in a loop all the way back here. And I've soldered a 5k6 resistor between where the red wire of the battery used to be, where this red wire from the 22Ks are now, and the track where the black wire used to be connected from the battery, so just there. And now, for the moment of truth, I need to test the voltage across the 5K6 resistor and see if it is indeed around 12 volts. Oh wow, that's really close. That's 11.8 volts across that resistor, which is close as it needs to be to the 12 volts that we were aiming for. Let's give the microphone a quick test. I'll just turn down my lapel mic. And I'm turning up the Realistic. There was a bit of hum actually, but it's definitely working. Let's see if I can put this back together. It might just be a shielding thing, and when it's in one piece, it's possible the hum will go. Let's see. Checked it and got rid of the hum, and I made this recording. Hi, my name's Gwem, and welcome to my wonderful YouTube channel. Hi, this is Gwem, and welcome to my wonderful YouTube channel. Hi, my name's Gwem, and welcome to my wonderful YouTube channel. Hi, my name's Gwem, and welcome to my wonderful YouTube channel. So it sounds really good. It's definitely the best recording that I've got from that microphone. But I have to question if it's worth the effort. Soldering onto the electret element was like a real pain. I think it's definitely worth doing the XLR conversion, but converting to phantom power is very fiddly. Probably not worth it. Maybe just stick with the batteries. Anyway, if you did want to go for the modification, it definitely does work. So I hope some people found this video interesting or useful. Definitely check out these mics. They're pretty cheap. Maybe don't go for the full modification, but an XLR on the end will definitely make it good. Take care and consider subscribing. See you next time.